Okay? Because we're going to convert the metric system a different way. And then once we learn how to do the metric system a different way, we're going to use that new system to do things that aren't metric. Because it works. The metric system, following the decimal point, only works with the metric system. This technique works everywhere. Okay? So, here is the definition of a conversion factor. Look it up in the back of your book, that's what it's going to say. A ratio of equivalent measurements. And I oftentimes complain about definitions. This is actually a good definition. It's defined on how you build it, not on what it does. Okay? How you build it. Okay? I have to make a ratio. Because that's what it says. It's a ratio. That means something over something. Right? And what do I want the things to be that are ratio? I want them to be equivalent measurements. Equivalent. Equal. Two measurements that are equal to each other. Can anybody think of two measurements that are equal to each other?
Milliliters to centimeters cubed.
Yeah, because 1 milliliter is 1 centimeter cubed. That's an equivalent statement. Is that the only one we learned? How about, because equivalent statements, two things have to be the same, right? So 1 meter is 100 centimeters? See how that's an equivalent statement? Two things that are equal to each other. 1 meter is 100 centimeters. So that gives me the equivalent measurements part of it. Now I just need to turn it into a ratio. And actually, I'm going to turn it into two ratios. I'm going to divide by each side. I'm going to divide by the 1 meter and get an answer. And then I'm going to divide by the 100 centimeters. And I'm going to get an answer. And that's going to give me two ways of writing the number 1. Two ways of writing the number 1. Okay. So I'm going to start off that 1 meter equals 100 centimeter. And we said we're going to divide by each side. So I'm going to divide by one side first. So I'm going to divide both sides by 100 centimeters. Is that okay to do? Algebra class says that if you do it to one side, you do it to the other, you can divide by the same number on both sides as long as it's not 0. Right? What happens on the right-hand side of this equation, though? They cancel out. And you're left with 1. They cancel out and you're left with 1. So 1 meter over 100 centimeters equals 1. Because the thing on the top and the thing on the bottom are the same size. I have a ratio of equivalent measurements. So this is the conversion factor. It's just a bizarre way to write the number 1. Okay? But I said I could do it twice. I could also divide by the 1 meter. As long as I do it to both sides, it's okay. And now this time, the left-hand side cancels out. N equals 1. So anytime I have an equivalent statement, remember I started with this equals that, I can always make two conversion factors. One with the first on the top, another with the first unit on the bottom. It's all about the units. Okay? It's all about the units are our friends. In the past, your teacher said you have to include the units, and you've forced yourself to do it, although you saw no reason for it. It seemed like a waste of time. Now I'm telling you the units will help you set up the problem. They'll help you get to the answer. Units are your friends. So another way you could talk about a conversion factor, it's a unique way to write the number 1. Because it's a ratio of equivalent measurements. It's something over itself. It's 1 written in a bizarre way. Okay. So equivalent statement, those statements we start with, they always have this relationship. It's the same relationship, it's that metric relationship. That the big number is going to go next to the small unit, and the small number is going to go next to the big unit. It takes a lot of small units to equal a few big units. It takes a lot of millimeters to equal meters. So just like that scientific notation had one side get big, the other side get small, same thing happens with units. One side gets big, the other way gets small. The fact is, you can think of the metric system, every one of those prefixes is really just a power of 10. It really is just scientific notation using letters instead of times 10 to the. Because every time somebody writes kilo, you can write 1,000 times meters. Okay? But there are 1,000 millimeters in 1 meter. That's an equivalent statement. It takes a lot of small pieces to equal one big piece. So let's write some conversion factors. Write the conversion factor between, write the conversion factors you can for kilograms and grams. What conversion factors could you write out of that? So I need a conversion. I would need this conversion factor if I was given so many grams and wanted kilograms. How would I do that? Well, first I have to start off with the equivalent statement. What is true about kilograms and grams? Well, which is bigger, a gram or a kilogram? Kilogram. So the big unit gets the small number, the kilogram gets the 1, and the gram gets the. Yeah, you need to know these prefixes. Somebody may ask them about you tomorrow. Ask you about them tomorrow. Okay. Now I know the equivalent statement. Now I can make the conversion factors. I can either put kilograms on the top, or I can put kilograms on the bottom. And I can put grams on the top, or I can put grams on the bottom. And now I just have to fill in the numbers. The number next to kilogram is 1. The number next to grams is 1,000. So I can write 2 different conversion factors with my equal statement. One with kilograms on top, one with kilograms on the bottom. Hugely difficult? We're just copying numbers. This is the hard part. This is the part you have to know. Okay? That's the part you really need to know what those prefixes mean. Okay? What if I asked you to do feet and inches? The conversion factors with feet and inches, one where it's not metric. Okay? You have to do the same thing. But you might come up in the middle of the test and ask me, Mr. Green, how many inches are in a foot or how many feet are in an inch? I don't know. You know what I would say? I would say 12 inches is 1 foot. I don't care if you know the English system right now. I care if you know the metric system. So if you come to me and ask me, Mr. Green, how many kilograms are in a gram or how many grams are in a kilogram? I'll say, you should know that and I can't help you. But if you ask me how many feet are in a yard, I'll say 3. Or I'll say it's on the test. There's enough information on the test for you to do it. I'll include stuff on the test for you to be able to get there. May have not have been exactly what you wanted, but there's enough there to get there. Does that make sense? I care if you memorize metric. I don't care if you memorize English. So 12 inches is 1 foot, right? Now, you don't even have to write this all the time. You know that the conversion factors are going to be feet on top and feet on the bottom. Inches on the bottom and inches on top. That's what it's got to look like, right? And I just have to fill in the numbers. What numbers? Well, which is bigger, a foot or an inch? A foot. So the foot gets the 1 and the inch gets the 12. The foot gets the 1, the inch gets the 12. Extra super tough? Pretty easy? Just copy those units, put one on top, one on the bottom. And then fill in the numbers. The hard part is memorizing the numbers. Okay? So, that's how you make a conversion factor. Why bother? What are they good for? Why do we bother to make conversion factors? Because their name tells us they convert. And what they're going to convert is they're going to convert units. Because we're going to multiply by 1 to convert the units. If I multiply by 1, I get something the same size. But I will get different units for something that's the same size. Does that make sense? Okay, this type of question. How many inches is 13? 13 inches is how many yards? That's 13 inches less than a yard, so it can't be 4. Right? Oh, you don't have to know that. There's 36 inches in a yard. There, I'll tell you that. You don't have to know that. I will tell you. Okay? We can't. This is like last night's homework where I said how many kilometers are there in 0.45 meters. But I can't just move the decimal point now because it's not metric. So I'm going to have to use a conversion factor. Okay. Now I can make 2 conversion factors out of 36 inches is 1 yard. I'm going to pick the one that has inches on the bottom. You'll see in a minute why I picked that one. I had 2 possibilities. I could put inches on the top or I could put inches on the bottom. I chose the one that inches went on the bottom. Okay, I made a choice there. Why did I make that choice? Because we said we were going to multiply by 1. So if I take my 13 inches and I multiply it by this is 1. 1 yard over 36 inches. That's 1, right? But look what happens to the units. I've got inches on top, and I have inches on the bottom. Those inches cancel out. That's why I picked the one I did. I picked the one that was going to cancel out inches. I knew I didn't want inches in my answer, so I had 2 choices. I could put the inches on top or the inches on the bottom. If I put it on the bottom, it cancels out. Everybody okay with this canceling out? One on top, one on the bottom. Okay. So now the only unit I have left is yards, which is the one they want. So all I have to do is push buttons on my calculator. So 13, I'm not going to push times 1 because that's lame. I will push, the 36 is on the bottom, So I push divided by 36. And my calculator gives me 0.36. So 13 inches is 0.36 yards. It's about a third of a yard, a little bit more than a third. Because 12 would be a third, so it's a little bit more than a third. See how that works? See why they're called conversion factors? They convert units. I started off talking about inches. I end up talking about yards. Right? So, they're easy to make, and we have to pick one of the two. We pick the one that gets rid of the unit. So, because they're called conversion unit factors because they convert units. It's really just creative multiplication. Creative, not a word you used to think about. You never connect with multiplication, but it's creative multiplication. You get to pick what you want to multiply by, and you pick the one that gets rid of the unit. You get to pick, and you pick the one that gets rid of the unit you don't want. So that's this whole technique. So the rest of the day, all we're going to do is apply this technique over and over again. That's what your homework's going to have you do. Apply this technique. Hey, this technique has a name, though. It's called dimensional analysis. Another name for it is the factor label method. Okay. Again, I like words that have meaning. Dimension. One of the definitions of dimension is unit. So you could have said unit analysis. The units. The whole secret to solving these problems is looking at the units. The units aren't something you do at the end. The units are something you do at the beginning. Okay? And when you analyze stuff, you solve a problem by tearing it apart into pieces. So dimensional analysis says tear it apart into its units so you can solve the problem. Using units to solve the problem. You don't have to come up with an equation. You just have to make sure the units work out. Because if the units of your answer are right, chances are you did the math right. If the units of your answer are wrong, you did the math wrong. And we treat the units just like x's and y's in math class. They cancel out, they multiply together. So x over x cancels out, x times x is x squared. Inches over inches cancels out, inches times inches is inches squared. The units are treated just like the variables. So, do the math right, you get the right units. You get the wrong units, you did the math wrong. So see what cancels out along the way. My units worked out on the last example. I started off with inches, those went away, and I got new units, yards, which is what they asked me for. Okay. The place people struggle with metric units is you have to know the equivalent statements. You got to memorize those prefixes. There's no way around it. Okay? So what equivalent statements do we need to know? You need to know the metric ones, what the metric prefixes mean. Okay? So if we had kilometers, I should know the relationship between kilometers and meters. Which is bigger, a meter or a kilometer? Kilometer. So the big unit gets the small number. The small number is a 1. And that means the meter should get a big number. What's the big number for kilometers? It's 1,000. Okay? I can go between meter and decimeter. Which is bigger? Meter. Fact is, of all our prefixes, the only one that's bigger than a meter that we use is kilometer. Okay? How many decimeters are there in 1 meter? Since it's 1/10 of a meter, it takes 10 of them to equal a meter, right? And I could also do that with centimeters. How many centimeters would it take to equal a meter? How many cents does it take to equal $1? 100. Okay? Then there was millimeters. How many millimeters? Mil, Spanish? 1,000. Then we had the bizarre ones, the micrometers. 3 zeros. 1,000,000. Or 10 to the 6th. I'm too lazy to write 1,000,000. I'm going to write 10 to the 6th because that's a lot shorter. And then there was nanometers. 1 billion, but I'm not writing 9 zeros. I'm going to put 10 to the 9th. That would be 9 zeros. Okay? Those are the equivalent statements you need to know. What if it's not meters? What if it were grams? It'd be the same thing. Isn't that the benefit of the metric system? Once you know the prefixes, you know them for everything. How many cups are in a gallon? I have no idea. I could figure it out, but it'd be a pain. And it's not going to be a decimal point, right? This is just going to be math with tens. I like math with tens. Okay. Okay, so those are the equivalent statements. So if I give you a problem and it starts with a prefix, the first thing you're going to want to do is get rid of that prefix. The prefix is going to go on the bottom, and the base unit will go up top. So I'll be able to use a conversion factor to get rid of a prefix. If I start off with centimeters, I can go to meters. If I start off with kilo Celsius, I can go to Celsius. Hadn't thought about temperature that way before, but there'd be kilo Celsius, right? Okay. And I can also use a conversion factor to add a prefix. If they give me meters, I can get rid of meters and change it into something with a prefix. Because I know meters equals something else. As long as I know meters equals something, I can change it into it. So you use a conversion factor to add a prefix, using a conversion factor to remove a prefix. So if you go from prefix to prefix, first you take off the prefix, and then you put on the prefix. It takes 2 conversion factors. One to get rid of the first one to add the second one. So this is what your homework's going to look like. Oops. 25 milliliters is how many liters? So I write the 25 milliliters that they gave me. That's where I need to start, writing down what they gave me. I write down the thing I want to change. And then I know I'm going to multiply it by 1, so I put a space to put my conversion factor. And then my guiding purpose, what unit do I want to get rid of? Milliliters. Where would I have to put milliliters so it would cancel out? On the bottom. What can I turn milliliters into? Liters. Notice I put the units in first, because the units are going to tell me where the numbers go. Because now I have to make it true. Which is bigger, a liter or a milliliter? The liter's bigger, so it gets the 1, and the milliliter gets the mille, 1,000. And remember, see, the hard part is memorizing the equivalent statements. because the units just go there. They set up the problem for you. You didn't have to decide, am I going to multiply or divide? This says thousands on the bottom, I divide. My milliliters have canceled out because there's one on top, one on the bottom. I set it up on purpose so that happens. That's the whole key to it. Make the units cancel out. And then 25, I'm not going to push times 1, but I will push divided by 1,000, which is 0.025 liters. The beauty of this, we can check and see if we got it right, because we know another way to do this problem, right? So I want to go from milliliters to liters, so I want to start here and go 1, 2, 3 to the left. So if I take my 25 and go 1, 2, 3 to the left, I get 0.025. I get the same answer. There are 2 ways to do this problem, so on tonight's homework, I want you to do it both ways and make sure the answers agree with each other. If they don't agree with each other, one of them is wrong, at least. Could be both of them, but at least one of them's wrong. So on tonight's homework, you'll be able to check to see if you got the right answer because you know how to do it another way. You're going to show me the work to show me that you know the new way. So I'll be looking at the work to make sure you know the new technique, and you can just write the answer down the other way because there's no work to show for bouncing decimal places, right? Oops. Let's try the second one. 5.8 times 10 to the negative 6 millimeters. And I want to change that to nanometers. And I start off by writing down what they gave me, so I know what I want to change. Because I want this to be equal to something else. Because this 25 milliliters equals this because I only multiplied it by 1. If I multiply by 1, I don't change its size, right? So 25 milliliters is the same size as 0.025 liters. I multiplied by 1. Okay. So I've copied down what I want to change. What unit do I want to get rid of? The millimeters. Where does it have to go? On the bottom. What can I turn millimeters into? Do you know what the relationship is between nanometers and millimeters? Do you want to memorize the relationship between all the possible combinations? No. So you don't try to go from prefix to prefix. You go from prefix to base unit. So I'm going to go from millimeters to meters, because that one I know. That one I'm supposed to know. Which is bigger, a meter or a millimeter? Meter. So the meter gets the 1, and the millimeter gets the 1,000. It was 1,000 on the last one. It's 1,000 on this one because it's still milli. Doesn't matter what you put milli in front of. Question? I taught them to you last week, so I'm comfortable asking you about the metric system tomorrow. Okay. Nothing new. Hey, but this diagram will help you. It's not, if you got that diagram memorized, how many zeros in kilo? 1, 2, 3. How many decimeters? 1, 0, 10. How many centimeters? 1, 2, 100. It's not that bad. If you got that down, you can figure it out pretty easily, right? It's not as bad as you thought, but really, you want it memorized so that you don't have to stop and look things up in the middle of doing homework. And you'll find that as you start doing these, you will memorize them without having to work at it, because you got to keep looking them up and say, why am I looking this up? Okay. I don't give you a whole bunch of things to memorize. There's a few lists of things I need you to memorize. This is one of them. Okay. But the list, it's only like 3 or 4 the entire year. Okay. So my millimeters are canceled out, and if I push this on my calculator, 5.8 EE negative 6 divided by 1,000 is 5.8 times 10 to the negative 9th meters. Are we okay with that? Okay, but that's not my answer. So I take that 5.8 times 10 to the negative 9th meters, and now I do another conversion factor. First conversion factor got rid of the prefix. Second conversion factor put the new prefix on. So what do I want to get rid of now? What do I want to get rid of? Well, the unit I have right here. Whatever that unit is, I want to get rid of it. In this case, it's meters. So I put meters on the bottom of my conversion factor. What can I turn meters into? I can turn meters into nanometers. I can put a prefix on. And 1 meter is a billion. Now I'm going to write 10 to the 9th. Okay? And my meters have canceled out. You could write the billion and type the 9 zeros. That's fine with me. But if you're going to use your calculator, you've got to be careful here. Okay? Because that 10 to the 9th is on top and you want to multiply by it. So you want to push 5.8 EE negative 9. Okay? And then times, you can't just push the E button. Okay? So in your calculator, make it 1 times 10 to the 9th. Isn't 10 to the 9th and 1 times 10 to the 9th the same size? So you type 1 EE9. Not 10 EE9, 1 E9. Because 10 times 10 to the 9th is 10 to the 10th. So I type 1 E9, and of course I get 5.8. Because 10 to the negative 9th times 10 to the 9th cancels out. Yeah. What was it? What was that? No, I don't want you to go prefix to prefix. I want you to get used to doing this. Part of this is to get used to stringing along conversion factors because you'll need multiple several times. So don't try to do it all in one conversion factor because I want you to learn how to do multiple conversion factors so that we can do other places where I need multiples. So I'm using this as a vehicle. For me, it's more important that you learn the math, the technique, than the metric system. Because the metric system will be there all year, but so will this technique. Getting rid of units and fixing them. Okay? Now, that was a lot of writing. But if you think about your calculator, you never had to type that number on your calculator. Because you did the first one, and it gave you 5.8 times 10 to the negative 9th. And then you wrote the problem, and you went to go do the second one, and the 5.8 times 10 to the negative 9th was still sitting in your calculator. So all you had to do was push divided by, or times 1E9. So why take the time to stop and write that down? We could have done that without stopping. And this is what it would have looked like. 5.8 times 10 to the minus 6 millimeters, and we wanted to change it to nanometers. Same problem. I'm going to start off in the same way. I'm going to get rid of millimeters and change it to meters. And 1 meter is 1,000 millimeters. Exactly the way we started the last one. Cross out the millimeters. But on the last one, I stopped and figured out a number here. I don't have to. I can just put in another conversion factor. I can multiply by 1 again. If I multiply by 1 again, I'm still not changing its size, but now my conversion factor is the second conversion factor, the one that gets rid of meters and changes it to nanometers. I don't have to do them as separate problems. I can do it all as one big problem. Okay? And which is bigger? Well, it was 1 meter was 10 to the 9th nanometers. My meters have canceled out. So see how the math looks just like the other one, except I don't have to stop and write a number in the middle. So I would push 5.8 EE negative 6 divided by 1,000, because the 1,000 is on the bottom, times 1 E9 on the top, and it gets me 5.8. I get the same answer. So why did this take 2 conversion factors and the other one only took 1? Because this one had a prefix to a prefix, the other one had a prefix and a base unit. Yeah. So try this one. Okay. So you set up your conversion factors for that. First one, you wanted to get rid of meters. And change it to millimeters. So you should have had 8.3 meters. Get rid of meters, change to millimeters. 1 meter is 1,000 millimeters, 8,300. So, tonight, I want you to show your work. And then you can check with the table on the top. Make sense? Okay. Have a good afternoon.